Okay, in this lesson, we're going to learn about transformations of functions. By the time you're finished this lesson, you'll be able to analyze transformations of functions. First of all, I want you to do the warm-up. So pause the video, and I want you to graph each pair of functions in the same coordinate plane. So first of all, we graph the function y is equal to x. Notice we're going up 4 units on this one. When we graph y is equal to negative 2x, we're going down 3 units on the second function. And then y is equal to x, and we're going to go down 2 units on the second function. Okay, reflection flips the graph of a function across a line, such as the x or y axis. So for the function f of x, the reflection in the y-axis is f negative x. For the function f of x, the reflection of the x-axis is the opposite of f of x. So let's look at what that means. So we've got this function. Let's write the rule for each function reflected in the given axis. So what is the rule for a function 2x minus 1 reflected in the x-axis? Notice we changed the sign on both of them. Change the coefficient for the x to a negative 2x and then plus 1. Now for the y-axis, when we're reflecting across the y, we only change the sign of the first, the variable, negative 2x. So let's try this for the x-axis. We change both signs. But for the y-axis, we're only going to change the sign for the x value. Okay, let's look at a vertical stretch. That means that we're going to multiply all y values of a function by the same factor greater than 1, where a compression reduces all y values of a function by the same factor between 0 and 1. So you think compress small numbers, 0, 1, you're talking fractions. In other words, let f of x be the parent function. So if a is greater than 0, then we have a vertical stretch. If a falls between 0 and 1, we have a vertical compression. We're to graph each of the following in the same coordinate plane and create a table of values for each. Then explain the transformations from the first equation. So first of all, we have y is equal to x squared. Okay, we have a parabola. When we have 3x squared, okay, so we're multiplying by 3, so it's going to stretch by 3. Now when we multiply by 1/3, we compress by 1/3. So if you've got your graphing calculators with you, why don't you go into Function Editor and enter in each of one of these and look to see that you get the same thing. And you can practice with other functions as well. The graph of g of x is the graph of f of x is equal to 6x, compressed vertically by the factor of 1/2, and then reflected in the y-axis. So what is the function rule? Well, first of all, if we take half of 6 or multiply 6 by 1/2, we get a 3. It's reflected across the y-axis. We're going to change the sign to a negative 3x. Now, what transformations change the graph of f of x to the graph of g of x? So let's look. Here's f of x. So what are we doing to f of x in order to get g of x? Well, it looks like we're multiplying by 3 and then going 1 unit down. So we're going to stretch by 3 units and we're going to shift vertically down 1 unit. This is the concept summary for the last 2 lessons, where we've learned about translations and now reflections and vertical stretches and compressions. So make sure that you have all this information in your notes. Keep it handy. It's very helpful to use these kind of notes when you're working your assignment, which, by the way, you're ready to begin.